Welcome guys to a new video. It's a question 3 from a paper 2 exam. So we have a company that produces bags of sugar whose masses in grams can be modeled by a normal distribution with a mean of 1000 and a standard deviation of 3.5. A bag of sugar is rejected for sale if the mass is less than 995 grams. Question A, find the probability that the bag selected at random is rejected. So first of all, let's write this data. We have the mass, okay, to be normally distributed with a mean of 1000 grams and the variance of 3.5 squared. Okay, so we are going to put this on our distribution to have a little bit of a visual understanding. It looks like this. The 1000 goes there. And for question A, we want to find the probability that the bag is rejected. The bag is rejected if the mass is less than 995. So we want our mass to be less than 995. We go to our calculator, we use the normal CDF. And in the normal CDF, we'll be using the lower bound, which we're going to put as negative infinity, upper bound of 995, the average, the mean of 1000, and the sigma, the standard deviation of 3.5. We put all these things together, we will find the answer to be 0.0766 at 3 significant figures. Okay, so that's going to be our probability. For question B, it says estimate the number of bags that will be rejected from a random sample of 100 bags. So if we have to estimate something, we will have an expected value. The expected value of bags being rejected will be equal to the probability of being rejected, which is 0.0766, multiplied with the sample of 100 bags. And that's going to be 7.66, or roughly 8 bags. Since the number of bags is an integer, we can just round it to 8 bags. Okay? And finally, for question C, we're going to do the following. Given that the bag is not rejected, find the probability that it has a mass greater than 1005 grams. So find the probability that the mass is greater than 1005 grams, given that it's not rejected. We know that to be rejected, the weight must be less than 995. Not being rejected should be the opposite of that, which is greater than or equal to 995. With that being said, we can apply the conditional probability formula and we will have the following. We will do the probability of the mass exceeding 1005 and the mass exceeding 995 divided by the probability that the mass is greater than or equal to 995. Now, what does this mean? The numerator. If I have the distribution of mass and I want it to be above 1005 and I also want it to be greater than or equal to 995, the double intersection is over here. So I'm just going to consider the probability of the mass being greater than 1005 divided by the probability that the mass is greater than or equal to 995. Both of these values can go into our calculator. We can do normal CDF for each. Mass exceeding 1005 means the lower bound is 1005, the upper bound is positive infinity, the mean is 1000, and the sigma is 3.5. And then for the second probability, we have the mass exceeding 995. Well, we're gonna do the normal CDF again. The 995 will be the lower bound, the positive infinity will be the upper bound, the 1000 will be the mean, and 3.5 over there. The answers of the respective probabilities, numerator we will have 0.0766, for the denominator we will have 0.9234, and the division will bring us to the value of 0.0829. 0829. That's it. This concludes the exercise. Hope this makes sense. We are done. If you like the video, please drop it a like, subscribe to the channel, and I'll see you in the next one. Bye.